In this video, we're talking about absolute value inequalities, and again, it should be reviewed. What's going to be a little bit new is most teachers have probably taught you the rules that you see here, and I'm not going to read those for you because you've seen them before and you can read on your own. Most teachers have probably showed you how to do this by algebra, and I'm going to go over that, yeah. But what I'm going to do that might be different is show you how you can actually graph and solve these using the graphic calculator. So in example 23, I see that the absolute value is less than 11. Well, since it's less than, I'm using the top rule, means it's between, so it's an AND problem. So I'm going to just set it up. The absolute value just kind of drops out. Less than, we do it on both sides. And we end up on the right side as a positive 11. We just keep them the same, and then negative 11. That's just a setup. We're following this top rule because it was a less than problem. Less than means and I can see that because my variable is in the middle. Now, like we did in the previous video when we talked about compound inequalities, we're going to draw our loops. That's one inequality we're solving. Here's the other inequality we're solving. Okay, so for the first one, I have negative 11 less than 2x plus 7. And 2x plus 7, oops, I want that in green. X plus 7 is less than positive 11. I want to solve each of these. I'm going to start off with the red inequality. Start by subtracting 7 on both sides. So I have a negative 11 minus 7 is negative 18, less than 2x, divide by 2 on each side. So I have, oops, let's come down here, give myself a little bit more room. So I have negative 18 divided by 2 is negative 9 less than x. And, just falls down, minus 7, oops, hit the wrong color, minus 7 on both sides. 2x less than 11 minus 7 is 4. Divide by 2 on both sides. So x less than 2. Now again, we could stop here, but I'm going to graph this. Again, we only had one variable. So I'm going to draw my number line, put 0 on it like we did in the previous problems. Negative 9 is to the left of 0. Positive 2 is to the right of 0. And again, I'm going to draw my circles. Each of these do not have a line under it, so they're both open circles. And now I want to shade. I start by reading from the variable side first. So x is bigger than negative 9 or greater than negative 9, so I'm going to shade to the right. Here I have x is less than positive 2, so I'm going to shade to the left. Since it's an AND problem, all that I care about is where does the overlap happen. So we solved this algebraically, but now what I'm going to do is solve this graphically. So what we're looking for were the values between negative 9 and positive 2. So to graph this, what I'm going to do is say the left side is always y1, the right side is always y2. Use my calculator. I'm going to go to y equals, clear everything out. So y1 is the absolute value. To get to the absolute value on our calculators, you just hit the math button, go to the number menu, and it's the very first thing, ABS for absolute value. Now, it gives you parentheses. Those parentheses represent your absolute value bars. So 2x plus 7 is inside absolute value bars, so that means 2x plus 7 has to be inside the parentheses. Now, you have to have the ABS out front. If you just do regular parentheses by themselves, the calculator doesn't know you're talking about absolute value. So be sure you hit that ABS function first. So we're doing y1, now y2 is 11, graph. I'm going to zoom 6 for a new picture. And I know I graphed two things, so this means I need to zoom out since I don't see both things. Oh, and now I have points of intersection. Let's find those. I have a good feeling that those points of intersection are going to be negative 9 and positive 2. Let's see if I'm right. Second calc, option 5. First curve enter, second curve enter. Guess. X equals negative 9. Exactly what we found. Second calc, option 5. First curve enter, second curve enter. Guess. X equals positive 2. Exactly what we found when we did it by algebra. So everything's good so far. Now, we had equals. We haven't taught anything about the inequalities left. So I'm looking at my original problem. I'm noting absolute value. The graph of absolute value is always a V shape. We've seen that before, and you've seen that in earlier classes. So what I'm looking for is the part of the graph where the V is less than the line y equals 11. Y equals 11 is a horizontal line, so we're looking for the part of the graph that is less than 11. So this part of the graph right here. Well, that means is that one of our values was x less than 9, or sorry, x greater than 9, because here's negative 9, here's x equals negative 9, and we want to be greater than, because the shaded part of our graph was to the right. Going to the right means greater. Here is x equals 2. We want to follow the shaded part of the graph. We're going to the left. That means we're going less than 2, x less than 2. So we see we can get these two inequalities from the graph. Now, if that's a little too complicated for you, then please do it by hand. But if the graph makes sense to you, then please do it by graphing. Whatever works better for you, I don't really care, as long as you get the correct answer without cheating. Example 24, I want to solve. I want to do this one first by graphing. So y1, y2. Okay. Clear it out. So y equals, again, ABS. I have 3x minus 2 on the inside. Close it up. Very important that you close it up, and y2 equals 8. Zoom 6, because of new picture, and I see my 2 points of intersection. Now, I'm going to use x. So x, it's a greater than problem, so this is an OR problem, and x. Okay, so what I want to do now is figure out what those points of intersection are. The second count, option 5, first curve enter, second curve enter, guess. Let's find the one on the left first, negative 2. Now, I'm not going to say x equals negative 2, I'm just going to write negative 2 over here, because I don't know what the inequality is yet. Now I'm going to find the one on the right. Second count, option 5, first curve enter, second curve enter, guess. Move my cursor over to the right. And I get x equals 3.333. Now, you can round, sure, fraction is better, but since I don't know what that fraction is, I'm just going to call it 3.3 repeating. 3.3 repeating. I think it's 10/3, so I'm going to try that in my calculator just on a hunch. Oh, and it is. So you can either do 10/3 or 3.3 repeating. I'm fine either way. I'm going to leave it as a decimal. Now I'm going to go back to the graph. What the graph is telling me is I'm looking for the part of the graph, the V for absolute value. Absolute value is always a V shape that is bigger than the line y equals 8. So we're going above. So this piece and this piece. We're looking for the two wings. We know this point right here was negative 2. Well, to follow the shaded part, we have to go to the left. So going to the left means less than negative 2. So x is less than negative 2. And we see a line underneath the problem, so it's going to be actually less than or equal to negative 2. Here, I know this point was 3.3 repeating, or 10/3, whatever you preferred. To follow the shaded part, I have to go to the right. I know that means greater than. And again, since I saw a line in my problem, we're actually going to use greater than or equal to 3.33 repeating. So we solved it by graphing. Let's go back and do it by algebra. Since it's a greater, I'm going to go back and look at my rules. Since it's a greater than problem, that means it's OR. I'm just going to set it up. The absolute value is going to drop out. Less than the opposite of what I have here, and greater than what I have here. So, setting it up, you should have seen this before. 3x minus 2 greater than or equal to 8. Oops. And actually, let's set that one up over here so it lines up. 3x minus 2 greater than or equal to 8. And 3x minus 2 less than or equal to negative 8. Again, I'm just following that rule on the previous page. You've seen that rule before in earlier classes. And now I'm going to just solve each of these. Plus 2, with 3x less than or equal to negative 8 plus 2 is negative 6. Divide by 3 on both sides. So x less than or equal to negative 6 over 3 is negative 2. Exactly what I found here by graphing. Great. So plus 2, graph 3x greater than or equal to 10. Divide by 3 on both sides. So x greater than or equal to 10 thirds, which we already saw on our calculator. 10 thirds is 3.3 repeating, so we've got that. Our inequalities match up perfectly, so we've solved this. You could draw a sketch on the number line. Again, one variable means graph it using a number line. I'm not going to do that this time. Okay? So again, whatever you prefer, solving by graphing or using the algebra rules. I don't really care. But all of this is review, so if you've got questions, please let me know.